Hello, everyone. My name is Søren. I'm the co-founder of Prisma. I'm very excited to welcome you to the Serverless Data Conference, where we will dive deep into the topic of databases for serverless applications. But why dedicate an entire conference to serverless data? Well, first, because serverless is a really exciting technology for developers. It allows you to start for free and promises to scale to massive production workloads with no infrastructure to manage. We have seen our community choosing serverless runtimes for their projects a lot. With services like Netlify and Vercel really leveling up the developer experience, it's really no surprise that developers are choosing to rely on serverless for their applications. But not all is well in this new world of serverless. While serverless compute feels like a mature technology by now, serverless databases still have a long way to go. Today, you will hear from some of the companies at the forefront developing serverless databases. And we will show you how the Prisma Data Proxy can help you to use more traditional databases in your serverless applications. At Prisma, our vision is to enable any team to have its own reliable and scalable data access layer, while also making it easy to move fast and iterate quickly. For us, it all started with the Node.js ORM. We redefined what the developer experience looks like when interacting with databases. And we did that by providing advanced type safety support, great auto completion, and integration in your development environment. And that's why more than 100,000 developers have adopted Prisma for their applications today. The Prisma ORM supports a wide range of databases: Postgres, MySQL, SQL Server, and MongoDB, which was introduced earlier this year. But it doesn't stop there. Data access comes with challenges that require more than an ORM, especially when working in a serverless environment. And that's why we started working on what we call an application data platform. The application data platform will expand your Prisma project's capabilities and help any application developer to go faster, build bigger. To show you that, let me introduce you to Emily, who's going to show you what you can do on the Prisma Data Platform today.
Thanks, Søren. Hi, everyone. Let me show you how the Prisma Data Platform works. I've recently been working on a team building an e-commerce application for a large retailer. We created a first iteration of the project using Prisma. We would now like to deploy it on Vercel and collaborate on the data together. So we have a GitHub repository with our project available and a database set up on AWS and ready to go. Let's get started. After logging in with my GitHub handle to the Prisma Data Platform, I'm going to import my project. I'll click Import, select the repository, and give my project a name. All right, now it's time to configure the production environment. We already have our database, so we're going to paste the connection string here. Note that if we were starting a new project, we could provision a database with third-party providers like Heroku directly from this place, which is quite convenient. Okay, so we have the environment configured. Now it's time to deploy. We have instructions to define the environment variables here on Vercel. So after clicking deploy and following these instructions, the app should connect right to the database. We can then just let the build run. All right, now that the build is run and the app is deployed, let's check it out. So I can immediately see that the price on this bag is wrong. And there's also another product, a coffee mug, that's missing. And it should be visible here. We'll need to fix that. Let's go back to the Prisma Data Platform and figure out what's wrong. Using the data browser, I can see all my data over here. We can see that it's the same data from my application. The data browser makes it really easy to troubleshoot data-related problems in the application without leaving your browser. I can filter out the products to find the bag and fix the price. I'll click Filters up here, and I'll filter only for products that contain bag in their name. So here's my record, and I'll just manually fix the price. And click Save. Okay, so now that the price is fixed, let's have a look at that missing product. I'm going to remove the filter that I just added. And looking at all the records, I can actually see the missing mug is indeed there. That means there must be something wrong with the query. Let's check this out. I'm going to check the query used in the product listing page. It looks like the filter set by the query is only checking for products on sale, which it shouldn't be. I could update that and redeploy, but I'd rather make sure that this is indeed the reason before going through a whole new deployment, which will take time. That's where the query console comes in handy, since that allows you to run Prisma queries directly on the database. Let's take this query, paste it into the query console, fix it, and double check. So here it is. I've pasted it into the query console, and I'm going to make the adjustment to try it out. I was filtering out products on sale for some reason. Let's remove that parameter and verify the results. All right. Looks good. Now the monk shows up. We can now make the changes and push them with more confidence. And after rebuilding, we can get our page looking just as expected. Finally, I can invite the rest of my team to the platform so that we can all use this together. Each team member can be assigned a certain role that determines what rights they have in the data browser. So as you can see, the Prisma Data Platform allows you and your team to easily work on various database environments, checking queries and data directly from the cloud. This can save a lot of time as people need to verify aspects of your application and troubleshoot problems on the go. Now that things work and we're getting closer to opening the application to more users, we need to ensure that the app won't break when facing significant traffic spikes. There's a common problem with serverless applications that leads to exhausting database connection limits. It's not always simple to fix. Let me hand you over to my colleague Daniel, who will explain that in more detail.
Thanks, Emily. Indeed, serverless is great at seamlessly dealing with traffic spikes. No need to plan for capacity, you just let functions be spawned based on the application's needs. But there's also a catch when working with traditional databases that weren't designed to work well with this approach. The good news is that any project on our platform also has access to a data proxy to help with managing database connections. We specifically designed this to help with serverless applications, and let me show you how it works by unpacking a typical traffic spike in different scenarios. In a non-serverless architecture, user requests are handled by a bunch of servers. Each server can deal with a lot of concurrent traffic on its own by managing a pool of database connections. So when the number of requests scales up, only a few servers are needed to respond to the spike in traffic, and database connections are heavily reused throughout the spikes. Now, in an architecture using serverless functions, the situation is different, since a lot of new functions get spawned as traffic spikes. Concretely, that's roughly one function per request, and each function will open a new connection to the database. The first problem is that opening a connection to the database is slow, and thus increases the latency of each request. The second problem is that there are a lot of ways and chances to hit the limit of the connections allowed by the database, since functions and their database connections are much less likely to be reused. This overall leads to slower requests and having a portion of them fail. This and users facing errors, which is obviously not great. So, in short, in a serverless application, the number of database connections stays close to the number of concurrent user requests, while traditional architectures that use servers reuse those database connections a lot more. And so, we've designed the Prisma Data Proxy to respond to this challenge and give you the best of both worlds. Looking under the hood of the Prisma client, we see that it is composed of a Prisma client API and a query engine managing the connection pool. We built the data proxy by bringing the connection pool into a hosted service that handles them appropriately and scales according to the traffic needs. Also, it comes with a nice side benefit of reducing the bundle size of the application, which leads to faster function loading times. Now let's take a look at this in practice by running a small load test on our project. To demonstrate how serverless functions can exhaust the database connection limit, we're going to use this demo Ask Me Anything app. And this app has 3 serverless endpoints. One endpoint is used in order to submit questions, another endpoint in order to increment the reactions, and finally the endpoint to fetch all of these questions. So now we're going to run a load test and see how it performs under load. So here we have the load test, and this load test simulates 150 virtual users that are in a loop making requests to those 3 endpoints that I mentioned. Okay, the report for this load test has been generated, and as we can see, we have 631 failed requests. What we're going to do next is I'm going to set up the Prisma Data Proxy and run another load test to see how it performs with the same load test. Now that I've configured the Prisma Data Proxy and redeployed my app, I'm going to run the load test again to see how it performs. So here again, we have the same load test, 150 virtual users who in a loop are making the 3 API calls to those serverless functions. Let's take a look at the report. And here we have it, 4,737 requests, none of which have failed. This was just a quick taste of the Prisma Data Proxy. Okay. Now let me show you what happened when the data proxy was added to the mix. When a traffic spike came in, functions got created, but the proxy was handling connections separately. Connections got created as needed, not for each new function, which maximized their reuse. Now let's summarize. The data proxy enables you to enjoy all the benefits of what serverless has to offer, and work with the databases you know and love, like Postgres, MySQL, MongoDB, and so on. There's no need to plan your infrastructure's capacity. The application can scale seamlessly, while Prisma will optimize how to reuse database connections. Now, your app is ready for prime time.
Thank you, Daniel. The Prisma Data Platform connects to your code repository, your database host, and your preferred application runtime provider. As Emily just showed, this integrated approach enables you and your team to work on the database with confidence and speed. The data proxy acts as a bridge between your trusted relational database and the modern serverless application runtime. I'm really excited about this and look forward to see what developers will build using our platform. Everything you just saw is available today in early access. So make sure to sign up using your GitHub account and try it out now at prisma.io. Next, I want to show you how we are thinking about evolving the platform to support even more advanced use cases in the future. We are going to show you demos of early concepts that our teams are exploring. These demos are not actual products that you can use today. Instead, they are early concepts that we hope will give you a very clear picture of the direction we are going with the data platform. To start out, let me introduce you to Nico, who will start with a very popular topic in the serverless world, preview deployments.
Thanks, Søren, and hi everyone. If you have used Netlify or Vercel before, you have probably heard of preview deployments. They're so convenient. Preview deployments allow you to super quickly test a new pull request without messing with anyone else's version of the app. And that makes everyone a lot more productive. But the thing is, preview deployments fall short as soon as databases are involved. And we would like to fix that. What I'm going to show you now is a very early concept demonstrating what we have in mind to make sure that databases are smoothly integrated into all of your preview deployment workflows. We would love to hear what you think about it, so let us know your feedback. To illustrate our idea, let's come back to our team that's building the e-commerce application for a large retail brand. As I've heard, some changes are needed in the application. We have heard from the marketing department that a more detailed description of the product categories is needed. To achieve that, we need to update our database schema and change the type of the category field from a text field to a full-blown category model with a relationship to the product model. This is a breaking change, as the category field on the product model now represents a relation rather than a simple string. We're changing the category field from string to a relation with its own model in the Prisma schema. After adjusting the Prisma schema file, we use Prisma migrate to generate and execute the migration in order to apply the change. And finally, we push the change to a feature branch on GitHub and now get access to Versal's nice preview deployment that includes the change we just made. Let's check it out. Uh-oh, what's that? A 500 error that says database not found? Why is that? Well, what Versal is doing here is mapping my feature branch to its own isolated deployment. Usually this is great, but in this case, the problem is that my preview deployment doesn't come equipped with a database. And that's why the server crashed with the error 500 code before. So how can we solve this and make sure a database is available for my preview deployment? Well, we cannot use our production database, of course. So we rather need to manually set up a preview database and hook it up to our preview environment. But now the problem is that we don't have full isolation. All preview deployments will be using the same database. And as a consequence, there's a risk that database schema changes on one PR are incompatible with the ones made on another PR. For example, this is what the author of another feature branch would see if they opened their own preview deployment, since the new category model I added to my schema doesn't exist in theirs. In an ideal world, each preview deployment would automatically get its own preview database that matches the schema of the respective branch. This is exactly what we have in mind for Prisma. Meet preview databases. With preview databases, the experience would look more like this. First, a friendly Prisma bot joins your pull request and provisions a preview database for you. It then applies your schema changes by running a migration and even seeds data into that new database so that your preview deployment looks realistic immediately. With this approach, every branch can be fully isolated from one another. Having this workflow would be absolutely amazing already, but we think we could still do better. Did you notice that step where data gets seeded into the preview database? Seeding generally is great, but always getting the same data might not always be as helpful to ensure your app is really working as it should. So what if you could configure what the seeding step does? Let's dig a bit deeper into this idea. Testing applications with realistic data is hard because of several factors. You want to seed data that mimics the data that you have in production. But you can't show any personal information, secrets, or sensitive data to stay compliant with government regulations. And finally, seeding should be fast and use a reasonable data sample size. To illustrate this better, imagine that your application has this account page using data directly copied from production. Well, this isn't good, since we can see real data from a real user. This breaches a whole bunch of regulations in most countries nowadays. What Prisma can do is to lean on its schema file by enriching it to qualify data as being sensitive, like personal information, or secret, like passwords. We can customize the seeding step to decide on a logic to apply there, such as faking emails or generating random data for passwords, for example. This way, your preview can now safely be used without putting you or your company at risk. And to bring this further, the Prisma Data Platform could give you options to customize the preview database's size or region. This would allow you to get realistic data faster without triggering massive workloads. We are incredibly excited about the idea of preview databases, and we would love to hear what you think about it too. To summarize, preview databases would give you a fully isolated preview environment with its own database that already comes equipped with realistic data, while giving you various strategies to randomize data from your production environment to stay compliant with government regulations. This way, your entire feature development workflow becomes completely integrated. Very little overhead and a huge jump forward in terms of developer experience. At Prisma, we want to make developers more productive so that they can spend time building valuable features. And we think preview databases will greatly contribute to that. Speaking of, I hear that Alex is going to show how to deal with a situation involving multiple data sources. So let's see what that is about.
Wait a minute. Okay, got it. Yeah, thanks, Nico. That's right. I'm helping the team with an issue regarding the search functionality, which is not performing well at the moment. Sometimes it gets really slow, and we're hearing from more and more customers that they're unable to find what they're looking for. This is even causing us to lose revenue, so we must find a solution fast. Let's see what we can do and how Prisma would ideally help there. As developers, we know that search is a solved problem. We introduce a dedicated search database such as Elasticsearch or a search service like Algolia. Then we ensure to write the product name and description to the search database so that we can leverage the advanced search functionality to deliver a better user experience and solve the problem. Right? Well, no. Unfortunately, it's not that simple. As soon as we start making updates to more than one database, we run into the dual write problem. We all know that a network request or an application can fail, and it's important that to make sure that when this happens, we don't leave an inconsistent state behind. When working with databases, we can normally depend on transactions to take care of this. But transactions only work in the scope of a single database. So in this scenario, what could happen is that a new product is added to the application database, but before it's added to Elasticsearch, the application fails. This means that the new product isn't searchable, although it's available. The solution to this problem is to write to the primary database and have the data propagated to the search database in a consistent manner. A popular way to achieve this is using the change data capture pattern. The industry standard for implementing this is called Debezium, which is built on top of Apache Kafka. We are looking to extend the Prisma Data Platform to support this pattern in a way that is optimized for serverless applications while still being compatible with industry standards. Okay, that was a lot of theory. What I'm about to show you is a very early concept of how we expect this to work. So keep in mind, while the syntax is just an example, we want the overall flow to be very close to the final product. If this sounds useful to you, then we'd love to hear from you so that we can make sure to incorporate your ideas and requirements into our final design. Okay, let's jump in. Here's a simplified Prisma schema showing the models relevant for this example. The first step is to introduce a new data source along with the product search index model in the Prisma schema. We'll use Elasticsearch in this example, but you can imagine doing this with your favorite search service. Note that Prisma currently only supports a single data source, but connecting it to multiple data sources is something we're considering adding soon. With this, you could already implement the dual write pattern by manually updating the data in both databases. But as we discussed, we need something better to avoid data inconsistency. Now, we want to take data from the first data source and project it into this new Elasticsearch index. We'll do that by defining a projection that is responsible for propagating changes. With this syntax, we define that the values of certain fields in the product model should be automatically propagated to the product search index in the Elasticsearch database. Under the hood, the Prisma Data Platform takes care of all the plumbing so you can focus on your business logic of your application. With these changes, I can now create a new pull request that contains this data projection. Creating the PR will trigger creation of a new preview environment. However, our preview environment creation will fail since we haven't defined our connection details to our Elasticsearch database. So let's go ahead and do that. Any project on the Prisma Data Platform has the ability to define multiple environments so that this is easy to customize settings for these. We can now go ahead and define the new preview environment variable to fix the problem. Now we're all set. The PR is green. We can go check out the details how this works by clicking on Details. In the project view, I can look at the data projection I just added. And then I'll trigger the backfilling of existing data into the product search index. We can check out the backfilling happening here and verify that the data is being pushed into Elasticsearch with every change. And with that, our search issue from earlier is resolved. We can now rest assured that the search works and we don't lose revenue or hair over this. So let's recap what we've been envisioning here. With a couple of changes on the Prisma schema, we would be able to create data projections across data sources almost instantly. This allows you to forget about the infrastructure components needed to make this happen. Prisma would provision, operate, and monitor the infrastructure needed to make this happen, namely the components required for the change data capture pattern, as well as the persistent queue for offering a fully integrated alternative for Debezium and Kafka. This would guarantee that the application and search databases are always in a consistent state and enable straightforward backfilling when the data projection is deployed. You can imagine other usages for this, like building real-time subscriptions, projecting results of a complex query to a caching layer, or projecting data to a reporting system. Now, back to you, Zoran.
Thank you, Alex. This concludes a glimpse into the future of the Prisma Data Platform. The data browser, query console, and the data proxy is available today. I hope you're excited for where we're going next with the data platform. The data platform is still in preview, and it's important for us to learn from you about things that aren't quite right yet. So as you start exploring the platform, please take the time to tell us what you think, what features you would like for us to work on next. For the rest of the conference, we have some very interesting talks lined up. I hope you will learn something new, and hopefully you'll have some interesting takeaways to share with your team. Please enjoy the show.